This week, we'll continue with our discussion about selections. Before I get started, I'd like to remind you again, if you're interested in doing some extra work to have more practice about if statements. Last week, I assigned you to really study the videos from number 10 to number 17. So these are the basics for if statements for the tutorial videos. If you want to study more for this week, you can study for videos number 18 and 19. So I also mentioned these two videos in your weekly tutorial for Java. Okay, it's up to you if you want to do some extra practice. All right, so now let's start from this week's topic. We'll continue, first of all, talking about logical operators. And something I assume is you kind of get yourself familiar about the three logical operators. I wouldn't really review their definition, but we're going to need that in order to give you more insights into the discussion and see how we can use them in the context of programming. Let me just remind you quickly, we got logical negation, we got logical conjunction, and also we got logical disjunction. And for logical negation, it's very easy. You simply just flip the result true to false, false to true. For logical conjunction, all you gotta know intuitively is the only way to really get a result of a conjunction to be true is when both operands are actually true. Otherwise, it's simply just going to be false because either or both of the operands are simply false. Symmetrically, so when you talk about logical disjunction, the only way to make the result false for logical disjunction is when both operands are actually false. If either or both of the operands are actually true, in that case the result is going to be true. That's really the essence for these three logical operators. Okay, let's now start with the slides for this week. So we'll start by talking about logical laws for all the three logical operators. Let's start with the negation. That's the easiest one. And then we'll go on to the logical conjunction and disjunction as well. Okay, so the negation of a strict inequality is simply a non-strict inequality. Okay, so let's see what I really meant over here. Let's just see one example over here, and then you'll see the rest. Let's say if I got a relation here to say I should be strictly larger than J. Okay, and now if I want to take the negation of that, so which means I want to say it is not the case that I is strictly larger than J. Remember, between any two integers or any two numbers, I and J, so there are only three possible relations. Either I is strictly larger than J, or I is equal to J, or I is strictly less than J. Only these three possibilities. And now we are saying that possibility number one is not the case. So that means the remaining two possibilities should be the case, right? So that means I is less than or equal to J. All right, let's do another one here. You can see now we are saying that larger than and also equal to. Larger than or equal to. And now we are saying that these two cases are not the case, right? Negation over here. So that means the third one should be the case, which is strictly less than. Okay, hopefully you get the idea, and then you can see the rest. So now, if we say I is less than J, the third possibility over here, if the third possibility is not the case, so that means either the first or the second one should be the case. So that'll be larger than or equal to. It's very easy to see the table. All right, so for the rest of the table, I'll leave that to you to really read it over. And now I want to go over this particular example over here. Conceptually, so here you can see action 1 and action 2. So these are just conceptually the body for the corresponding branch. And then I want to talk about how you should really interpret the implicit conditions for the branch. And then we'll use another more concrete example. Let's now switch over here. All right, so this is the table which I just talked about. Okay, you can refer to it. And now I want to talk about this particular if statement over here. It's a single if statement on the left. There is another single statement on the right. Okay, so we got two branches. I want you to pay attention to just the blue one. The blue one is action number 1. And the blue one over here is also action number 1. However, I kind of arrange them in the reverse places over here. Let's see here. What you want to know is, when would I actually execute action number 1? I will execute action number 1 only when I is strictly larger than J. It's evaluated true. Agree? So this one's easy. So just be I larger than J. What about in the on the right hand side? when I actually execute action number 1, so what does it really mean? So that means the else part is the case. And we know that according to the semantics for if statements, if I go to the else part, so that means this part over here is not the case. So this part over here is not the case. So not the case, I less than or equal to j, we know that it's equivalent to I larger than j. So we know that this part here will be I larger than j. So you can see these two are actually equivalents over here. You can see I will execute I larger than j. I will execute when I is strictly larger than j in both the left and the right. So far for action number 1, they will be executed under the precisely equal or equivalence conditions. How about the pink one very quickly? It's kind of symmetric. Let's just do that for exercise. So under what circumstance would I actually execute action number 2? I will go to the else part. Simply means this part over here is simply not the case. So if I say this part is not the case, I larger than j. We know that it's equivalent to I less than or equal to j. So that means I will only execute action number 2 when I is less than or equal to j. Agree? All right. So what about the right hand side? Well, trivial, because you can see I will only execute action number 2 if this particular branching condition is actually the case. So that will just be I less than or equal to j. So now if you compare the two, on the left hand side, I will execute action number 2 under this circumstance, I is less than or equal to j. On the right hand side, I will execute action number 2 under this circumstance. So they are exactly equivalent. So now I can see for action number 1, they will be executed under precisely the same circumstance. And also for action number 2, on the over here, they will also be executed under the same circumstance. So now I prove that they are really equivalent. Right? It's a very easy, well, I shouldn't say easy, it's a very simple mind exercise I'm trying to do together with you to really see how to apply the logical law. So now let me just recap very quickly before I move on to another example together with you. Whenever you see a if and else, for example, let's say easy one. Whenever you see some explicit branching condition over here to be a relational expression, you should always think about what's its negation, because its negation will be precisely the condition under which the body of the else is going to be executed. So that means here is I larger than j, so that means the else part will only be executed when its negation is actually true, meaning that this branching condition actually fell. Alright, so that's a takeaway lesson for you. I actually got over here actually 2 test cases for you. I'm just going to do one of them, and then the other one I'll leave that for you as an exercise. Let's say I is 17 and also j is equal to 3. All right. So now let's say over here when on the left hand side. So 17 larger than 3. 17 larger than 3 should be true. So that means I'm going to execute action number 1 by passing the else part over here. So what about the right hand side? Since they're equivalents, so even though we have arranged the branching condition in the reverse way, but we will still end up executing action number 1 since they're equivalents. Let's try. So now if I try over here, I less than or equal to j, so 17 less than or equal to 3 is definitely false. So which means I'm going to bypass this part over here and then simply go to the else part, because implicitly that simply means the negation of I less than or equal to j, which means I larger than j, right? That's exactly what we just said. So we're going to execute this as well. So we ended up doing the same action 1 and also action 1 over here. All right, so I'm going to leave one more input over here for you to do some mind exercise over here, and then I'm going to move on to one more example for logical negation. Let me switch back to the slides. So the example I would like to talk about now is about our circle calculation. But now I want to show you some practical application about how to understand the different flavors of doing error handling. And then the way to understand that will be you have to understand the logical negation law that we just talked about. Okay, let's say we want to calculate the area of circle based on the user input about radius. Okay, very easy. We still got scanner and also prompt for the user and for double value for the radius. Okay, so now everything is familiar. Let me just go right to the point. In version number 1, for the if branch, we simply say if this is the erroneous actually condition to say radius is actually negative, which means it's invalid. In which case, we're going to print out the error message. Okay, and then otherwise, we're going to selectively calculate the area over here. Okay, so that'll be version number 1, where the erroneous condition is simply specified as the if branch over here. Okay, let's see the second version. And now I'm going to reverse the order of erroneous condition and also the valid condition. Okay, so now version number 2, you can see compute area 2. You can also find these two classes, compute area and also compute area 2, in your Java project archive, which we imported from last week. You can also import it as well. I'll show you very quickly. So if you go back to your Eclipse over here, you will see under selections, you will see compute area and also compute area 2. I'm just going to trace them in a moment on the iPad. However, since we have done so many times about debugger, I'll leave that exercise to you. So this week, I may only trace just a few examples, not every one of them, just to save time. All right. But I'm going to rely on you to really do the exercise for your own good. Hopefully, I can trust you on that. All right, so now for area number 2, version number 2. So now we're going to put, you can see radius larger than or equal to 0. So this will be the condition for valid inputs, which means implicitly, if we go to the else part, that means the erroneous condition actually is satisfied. Right? So that's the idea about the 2 versions. Let's take a look very quickly about tracing. So to really, we already learned about the theory over here to know about the logical negation, which we just did. Let's see these 2 examples. All right. So now you can think about over here. Let me use the green color to really say that's a valid condition. You can see in version number 2, we say if radius is larger than or equal to 0. That's a valid condition. And the else part is simply just over here about why. So this is important to see. I'm just going to tell you that. So when we get to the else part, so that simply means the if branch over here is actually false. Agree? So if it is false, so that means it is not the case that radius less than 0. And we just learned about the logical law. So that will be equivalent to radius larger than or equal to 0. Okay? So this is precisely the condition under which we're going to do the normal calculation for the radius circle, for the area of the circle. All right. And on the right hand side over here, you can see that's we're going to calculate the area of the circle directly under the condition when radius is larger than or equal to 0. Okay, that's one way to see it. What about the other half? What about when do we actually print out our error messages? For example, you can see in the first case, if this particular condition is actually true, that means the radius is strictly less than 0. In that case, we're actually going to execute this part over here to really say error. Okay, what about right hand side? Why is that equivalence? You can see on the right hand side, we will execute the error message if we get to the else part. And when will we get to the else part? You can see when we get to the else part, that simply means this condition over here will actually evaluate to be false, which means it is not the case that radius is larger than or equal to 0, which is equivalent to, by our law of negation, it would be radius less than, strictly less than 0. So that's implicitly the condition over here, where we're going to output the error. You can see over here, let's see one more time. You can see this condition here is equivalent to this condition over here. And for these 2 conditions, you're going to output the error and output the error over here. And the other half, this condition over here is equivalent to this condition over here. And then in both cases, we're going to execute this part over here that is going to calculate the area of the circle. All right, guys, I hope that makes sense to you. So let me just trace again. Let me trace one of them to actually show you how things work. And then I'll leave the other one to you as a exercise to trace. Let me choose maybe this one over here. Let's say radius is equal to -5. And then by tracing this, I'm going to leave that as an exercise for you. Okay, so you want to trace this on both sides, both versions basically. Okay, so that'll be exercise. Okay, let's try -5 over here. Okay, let's now try the first version. So -5. We're going to evaluate this if branch So minus 5 less than 0 is going to be true. That means that we're going to execute this line over here, the body for this branch, and then we're going to execute to really print out the error message. All right, that's what's going to happen. What about the right hand side, the second version? We also, of course, after, on the left hand side, we're going to bypass the evaluation of the execution of the else branch. We're going to bypass. What about the second version? We're going to evaluate the first branch. So now minus 5 larger than or equal to 0 is going to be false. That means we're going to bypass this branch over here. And then we're going to go directly to the else part and then execute this. So we're also going to execute the printout of this particular statement. You can see we ended up executing the same branch over here for the same input over here between the two versions. And then if you try the other one, the blue one over here, you will see that will also ended up executing just this branch over here in both cases. Give it a try, and then to really convince yourself informally that these two versions of code are really equivalent. All right, so now let's move on to talking about the logical laws for the other two operators.